All right, so we're going to get started on our next unit, which is going to be on climate change. Now, climate change is one of the most important and pressing issues of our time. So first, let's talk about what climate is. Climate is the average weather of a particular part of the world at different times of the year, and we gather that information over long periods of time. So you think of a desert, and you think of a hot, dry environment, but can it rain in a desert? Yes, it can. But that rain is considered to be the weather. You should write that down. Weather is more of the short-term precipitation and temperature that we see in an area. If you think of the climate of the desert, the climate's going to be hot and dry. But yes, you may see some rainy days in there as well. In order to understand climate change, we need to understand which atom. See if you can guess which one it is. That is going to be carbon. Carbon is an atom that likes to bond with other atoms. It is the heart of climate change. Okay, so carbon is in the molecule carbon dioxide, which we know is a big part of climate change. It's a greenhouse gas. Okay, and so is methane. Here's a couple others. One is nitrous oxide. And then there are fluorinated gases. We won't talk too much about them, but know that they are a greenhouse gas. Listed at the bottom are the greenhouse gases you should write down: carbon dioxide, methane, nitrous oxides, and fluorinated gases. Okay, take a look at this chart. So we can see that carbon dioxide makes up most of our greenhouse gas emissions, okay? And most of that is with fossil fuel and with factories. You can see 11% of that carbon dioxide is with forestry, other land uses that are going to increase the carbon dioxide in our atmosphere, okay? But you probably didn't know that water vapor is actually also a greenhouse gas, and it's one of the most important elements in our climate system. Okay, and you can feel free to add water vapor to your list of greenhouse gases. Now, human activities only put a small amount of water vapor into the atmosphere. As you would probably guess, CO2 or methane are what we are generally emitting the most of. Now, to really understand how this works, think of the Earth, okay? We have the atmosphere outside of the Earth, so it's like this layer that's outside of the Earth, okay? Now, this layer helps to keep our Earth warm. We need it. It is essential. If we didn't have that layer here of the atmosphere with those greenhouse gases in it, our Earth would freeze. We would be in an ice age, okay? So we need a certain amount of greenhouse gases to keep our Earth warm. But if we have too many of them, then our Earth is going to heat up more. Now think of it kind of like a blanket that is covering, over the Earth. But it's not exactly like a blanket because it is transparent and things can move through the atmosphere. Okay, so some gases may escape and go out to space, but it does work in a way similar to that, kind of like a greenhouse. So it's like this area here that is going to keep our Earth at the right temperature, but we need to have the right amount of greenhouse gases. But there are also some natural ways that carbon is stored in the environment or it's given off. So volcanoes and fires give off CO2. That's a natural source. But sinks, so a sink is a place where the carbon can be stored. So places like lakes and streams, oceans, and forests are going to store some of that carbon. And that's a cycle that's been happening for millions of years. But there's a problem now that we have factories and we have transportation that is giving off so much CO2. We have too much of it in our atmosphere and we can't handle it. So, and that really started, of course, in the Industrial Revolution. More than 2,000 billion metric tons of carbon dioxide have been added to the atmosphere by our human activities, by what we do. Prior to the Industrial Revolution, you can see yeah, natural causes are going to cause some warming, but if you look over the years, we are really increasing how much we're putting out into the atmosphere with those greenhouse gases. Okay, so it's really kind of on us. So what's it called when you delay or postpone something, such as a large science project at the very last minute? I don't think we've ever done that, have we? That's procrastination, you guys. How does that project usually end up? Things I poked with a stick. So it's not some of our best work, right? We can't procrastinate this issue. Seriously, you guys, it's your generation, my generation, that's going to have to clean up this mess if we want to live in the place comfortably the way that we do. So we have to take it seriously. So I really urge you to please do that. Now I will be getting into what you can do to help this issue, but first let's talk about the carbon budget clock. So this is the amount of carbon emissions permitted over a period of time to keep the world within a certain temperature threshold. With the carbon budget clock, we have time left to switch our mode of energy and consumption so we can seriously reduce the amount of emissions that we're giving off. You can look up that carbon budget clock if you want to take a look at it. So what does this temperature threshold really mean? So it's our standard of living, we are driving everywhere. We're using fossil fuels, sources of energy that are non-renewable. So that's kind of where we're at with our future right now. Now, in our homes, we have air conditioning. We have a way to make our homes comfortable for us to live in. But guess who doesn't have air conditioning? Lettuce. And, any of the plants and things that are outside, animals. Okay, so if we have an increased warming, it's going to get too hot for all of our crops. It's going to be too hot for everything on this planet. We can't air condition the entire planet. Okay, think of all those organisms that need their stable temperatures in their environment. Okay? Think about life without those organisms. Without that life, we wouldn't be able to survive. Life is good with lettuce and other crops and, of course, all of the needs that we have, right? The important thing here is we need to listen to the people who know about this. We need to listen to scientists because they've been studying this. They see the data, they've noticed trends, and we need to listen. Listen to the people who know the most about it, just like we are with, the CDC. They know everything that we can know right now about COVID-19, and they're the ones that, we should trust. Okay, now take a look at these two articles. Try to decipher which one looks more trustworthy. Now, we talked about this at the beginning of the year. It's really important to know where your information is coming from, especially right now, on Facebook. You see all different posts about the virus. Be really careful about which ones you listen to. Look into the articles, okay? See who they're coming from. Google those people. If you read something and you're like, I don't know if that sounds right, look into it. Okay, there's a lot of information going on right now, going around on Facebook, so be really careful about what you listen to. Okay, so looking back on these articles here, so the one on the left, okay, environmental effects of increased atmospheric carbon dioxide. Okay, we can see there are names there. You could look up those names, see who these people are, what type of degrees do they have. Okay, look at their charts. They look to be well put together, but you really want to see who's putting this information out there. Okay, the one on the right, how world leaders were duped into investing billions over manipulated global warming data. Okay, there's also a name there. You could look into that person. Also, see we have dailymail.com. versus the other one. You can see the source there. You would have to go, it's a .org, okay, and it's a research article. So which one is more trustworthy? Okay, the one on the left, A, is a peer-reviewed article. Experts put this out. It's research, and you could definitely look into those people's names if you wanted to know more about it. So what does peer-reviewed mean? So this is an article that has been evaluated by many scientists, many people in that field. Okay? They've all looked at it and decided whether they support it based on data or not. So as of 2012, and this has likely changed quite a bit, but as of 2012, there were 13,950 peer-reviewed climate articles. 24 of those reject climate change. Okay, I did the math here, and that's 0.17% reject climate change versus the rest of those 13,000 some that agree that climate change is happening and we need to do something about it. Let's talk about how we got where we are right now. So, going back to humans first using fire on Earth, that was about 1 million years ago. Carbon dioxide levels never rose to dangerous levels at this time. Okay. For almost all of human history, wood was the primary fuel source for warmth and light, and it really didn't cause a lot of increase in carbon. Until we as humans found a way to borrow light. And there we have it, electricity. So we have light from millions of years ago. Okay, that goes into the trees. When life dies, that carbon is buried, okay, buried in the earth. Now, over millions of years, that turns into oil and gas, okay, borrowed light or carbon. Now, we can't replenish that. It takes millions of years to do that, so we are taking this resource that is non-renewable, okay, unless we want to wait 1 million years, and we're using it for all of our transportation, all of our needs, and that's where the problem is because we're going to run out eventually. And what it's also having a negative effect of emitting that CO2 into the atmosphere. Okay, so now you can write down fossil fuels, which are oil, coal, and natural gas. They're actually the remains of plants and animals from hundreds of millions of years ago. All right, so once you get that written down, that's going to be our last slide for today. We're going to continue with this on the next day that we have content. Have a good day.